Hi, Kevin Culp from Supermicro back at you. We've manipulated the data that was moved into an Excel spreadsheet, but before we get into the mechanics of that, I'd like to talk about these two file formats that you see on the screen. The first file format, Microsoft Excel Common Separated Values file or Common Delimited file, was produced through SCC. It was in a toolbar file. We actually took that information, pulled it into Excel spreadsheet, and then converted that particular file format to another file format, which is Microsoft Excel Worksheet. As I mentioned, if you're trying to use any type of pivot techniques with this particular file format, it never saves any of the metadata. So you'll be challenged to basically pivot on building some relationships with existing metadata that we pulled from the dump server component attributes within SCC. So that's a difference in the two file formats. So again, use the Microsoft Excel worksheet as a worksheet to be able to take that data, manipulate it through pivot tables. So I'm going to go ahead and pull up the Excel spreadsheet. While it's processing, give me a couple of minutes to sip on my coffee here. And once it's pulled up, we can then start looking at some of the rich data. So at this point, the file has been pulled up. Let me make this a little bit larger here. And let's really look at, first of all, the data itself. So the data is actually columnized in columns with various different information. So this is information we pulled from the server components table. So if you were to go and look at SCC itself, you would see each of these tables is broken down with the appropriate metadata, things like location, BMC IP address, product family, product SKU, motherboard, serial number, form factor, BIOS, BMC version, CP count, etc., etc. So the first pivot or relationship we basically built was a very simple table on basically pulling metadata out there to show the relationships between the types of product SKUs and what their families that are associated with. So you'll see here that this is color-coded to show you have a Cloud DC family, a GPU family, PowerEdge family, ProLiant family. So these would be basically third-party devices that we support through Redfish. Again, it's a product that supports third-party devices because of Redfish. We have intelligent agents that parse endpoints for iDRAC and ILO. And then, of course, we have also the Supermicro product suite, which provides a lot more metadata that we can expose within attributes that we actually harvest through Redfish endpoints. So you see the Twin family, Ultra family, UP family, and Wheel family, and you see their appropriate relationships for each of them based on a pie chart. And we have a grand total of 18. So why we're seeing 10 here, remember that a twin family has 4 nodes. So we're utilizing 2 full big twins, which are 4 for each node. So that's a total of 8. And then we're only occupying 2 nodes on the third twin chassis, with the other 2 as being unoccupied or not being used. So that's to show you the product family relationship to product SKU. The next one we're going to build is relationships with form factors. So a product SKU based on form factor. Perhaps you're looking for, show me in my entire element list all the servers that are basically a 1-socket server versus 2-socket server. And you can see here we have a GPU server, the PowerEdge and Dell ProLiant both occupy 1 socket. And then we have the various rack-mounted servers supporting 1U. We have a 2U 2-socket for our big twin platform, and then also one socket for a one-use server or a rack-mounted server, and then the DC cloud. So this gives you a breakdown to show you relationships based on form factors which are one socket or two-use socket. So you might be wanting to do capacity forecast planning to see where these particular servers line up in regards to some of the maybe applications that you want to migrate from one server to the other. There are various different use cases that you can look at from a standpoint of pulling this specific data. And of course, in our little example here, we're doing 18, but what happens if you had, say, 25,000 monitored hosts? How would you get a good cross-section of platforms across multiple global data centers being able to pull this information? So very, very powerful in regards to which assets that you have in your data centers and how you pull specific different attributes from those servers would be very attractive for DevOps or administrators to be able to take a look at. The next use case is based on system health. And so this is a little bit of a interesting type of clustered type of histogram showing you specifically relationships based on critical health that is sitting in a critical state. So maybe showing those servers that are in a critical state. Perhaps you're trying to look at it from a perspective of change forum and systems that you want to basically take down to be able to do some type of maintenance work on them. It shows the various relationships of servers that are in good health standing and ones that are in a critical health standing. And we detail various types of count of health on the what we call the y-axis, and x-axis is actual servers. So another interesting use case of data that you can pull from basically looking at it from a system health perspective versus critical roll-up versus good health standing of the server. The last particular example that I took a look at is DIMM sizing. And this is a very interesting type of relationship we built here based on how we want to factor essentially for capacity planning, such as looking at servers that maybe perhaps are sitting at 512 type of memory size. In this case, it would be the GPU family. And then show me all the DIMMs that are of larger size that you could look at maybe to migrate various different workloads in that require that extra memory footprint versus ones that maybe perhaps don't have a memory footprint, or ones that are not utilizing perhaps high core count or essentially a high type of CPU itself, whether it be a platinum server or bronze type of CPU. So I just wanted to kind of point out here too as well, you can easily come in here and make changes to the pivot tables if you wanted to manipulate it, or you can look at various ways that you can actually filter based on information. Maybe I want to filter based on the memory size itself, like to show me essentially the server that has of, say, 512. So I could come in here and basically uncheck these and then just show me basically the 512 itself, which when you're looking at lots of particular elements within the pivot table, sometimes you could be lost in the sauce with too much data that's being represented within your chart. So being able to filter on key attributes you're looking for to be able to size, such as to indicate or drill down that this GPU has a high memory footprint. So those are just a few of the examples that you could take the rich metadata that's being pulled from SuperCloud Composer to be able to pivot within very useful pivot tables to make those data-driven decisions or form decisions on perhaps taking things such as workloads, moving them over to other servers, or perhaps looking at change forum, various different ways that you can slice and dice the data that's being pulled from the data mining toolset of SuperCloud Composer. So we'll improve this as we go on, putting a lot more rich data into each of these different types of use cases, specifically for server components. We'll look at other aspects such as pulling CDU data and looking at water cooling tower data, PDU data. There's so much various different data that we can mine. So look forward to the next set of videos to follow that talk about the various different ways that we can go out and data mine interesting data from SuperCloud Composer, expose it within an Excel spreadsheet. Thanks for joining today. Have a great day, and I bid you a great day.